Good evening, everyone. Welcome to the Entrepreneur's Kitchen. This is episode number 40, and I thought of a very special, very interesting episode. So if not think about future, what else? I am looking forward to conversing tonight with Barbara Imhof at the other end of the line. Hi, Barbara.
Hi, Seda. Good
How
evening.
are you?
I'm good. Uh, it's quite a unique thing. I'm not such a cook, but I can improvise quite well, and I think that's very suitable for future space missions.
Absolutely, yeah, that's going to be probably mission critical. And the other mission critical things at the Entrepreneur's Kitchen, let me just talk about them briefly before we start and going deep into the conversation. First and foremost, we have Slido. So if you guys want to have a question, any comments for Barbara and me, please go to Slido 61048. That's our event code 61048 for Slido for any questions to Barbara Imhof, who is one of the co-founders of the LIQUIFER Systems. She is a space architect, as I've just said. We're going to be talking about what we're going to eat in space, what we might be able to grow in space, and also how we're going to live, maybe 150 years from now. I mean, not us, but our children, maybe. I'm not necessarily hoping to see that part. But Barbara, so I admire you because you're not only an artist, but also someone who can imagine a future where other people already give up thinking. In the entrepreneurial rounds, if someone is thinking about 20, 25 years, it's already probably a family business, right?
Yeah,
So,
right.
yeah, exactly. So how far does the timeline go? How far do you imagine?
Well, I think when we sometimes do designs for Mars habitats or Mars settlements, I think one really has to think at least 50, 60 years or further ahead. And
Mm-hmm.
and it's, when you try to put yourself into, these future people's shoes, then it's quite difficult because we always think from our today's perspective with our today's technologies. And
Mm-hmm.
obviously, when you look back, 50 years back, and you think, okay, what technologies were available, so it's very hard to project what will be available in the future.
Mm-hmm.
So because that should ideally be incorporated.
That's really interesting because when you look back, I mean, how much does the history in terms of technological development tell you? Because we try to think in exponential terms, but um, it's so difficult to just exponentially think in 50, 60 years, even if we look back. So how does that work?
Well, yeah, how can I say the trick with space flight, or the good thing or the bad thing, either way you want to see it, is that it's a very conservative business. And looking back 50 years, let's say the dawn of the Apollo era or the midst of it, then there are technologies, some of them are not even available today anymore, and we are
Mm-hmm.
currently companies like SpaceX and Blue Origin are reinventing the big, heavy lift launchers and rockets, which actually are able to take us to the moon or further beyond the Earth orbit. Because it's a little bit like the old knowledge, it has somehow disappeared, and it's you can only keep in knowledge or technologies alive when you're trying to improve them and constantly work on them.
Mm-hmm.
So in that sense, even the access to the space station currently is only through the Russian Soyuz rocket, and that is,
Mm-hmm.
it's as old as human space flight, the Soyuz rocket. Of course, it has had improvements and amendments and extensions, but the basic technology is as old as human space flight.
It sounds like a collaborative monopoly.
Yeah.
Yeah. Although there are many nations, there is only one one thing that can do that. I mean, you just mentioned Elon Musk because he was kind of able to. He wasn't the first one to think about reusable rockets, but he was the first one to really tackle that issue successfully. So what happens when you see these kinds of developments, and can you imagine other people asking and really going for these disruptive developments?
Yes, I think so. I think it was really a game changer. SpaceX appearing, in that whole business, and it has really propelled a lot of new ideas and new businesses and new companies, such as Blue Origin, for example, who is also one of the big emerging new space companies. And I think it really propels and inspires a lot of other people. And but one also has to see that it's not easy for SpaceX to really achieve all the milestones they set, but they set ambitious goals, and that's kind of refreshing to see after a longer period of how can I say, of business as usual.
Yeah, absolutely. Well, you wouldn't think that, in the space realm, people would go with business as usual. But as you say, it seems like a very conservative business. Before going into more detail, because I'm really, really interested, when you think about space and innovation, you would expect actually everybody to go all crazy. But then sometimes it's the opposite. So we also have to talk about food. I know that you have a better hook than I will have around food, because you are preparing food that is actually, growable maybe in space. Let's talk about that. Yeah.
Yeah, so I'm an architect, and with the LIQUIFER team, we don't have any nutrition specialists, on board, but we collaborate with them, and we had a larger collaboration under the lead of the German Aerospace Center in Bremen, and they, with them and 14 other partners, so large consortium, we built a greenhouse in Antarctica. And the interesting thing is that it's not. I have here, so this is what you normally imagine, this is how you would grow things, in soil, but actually they grow it without soil. So what you do is, it's called aeroponics, and you just fill, let's say, a plastic bottle. Let's have this with water, and have some cotton wool or so, put it in here, put some seedlings in here, and then from there you grow, and you just, make sure that there's enough nutrition here, maybe salt, potassium, and so on, a specific nutrition solution, and then you can grow your own salad from there, basically. And so this is called aeroponics, and we have worked on this project, the Antarctic greenhouse. And it's also interesting for future vertical farming in cities, and it serves both. It's a preparation for larger space settlements, for independence in space, for future habitats on the moon or on Mars. But it's also interesting for vertical farming, vertical gardens, because it's all, you can imagine this also as a smaller bottle, and then you can just put one on top of each other. It's not in bottles, but in trays. And then so on a very small area, you can grow a lot of salad, or, these kind of, that's what I got, these kind of tomatoes.
That's great. Yeah.
Or these smaller cucumbers, they're easy to grow.
Yeah.
And
so there is no fast food in space.
No, there's no pizza delivery. No, not yet. But eventually, of course, you can imagine that some things, like this.
Well, I remember us talking about this, and I found it so interesting because you said the food tastes just like you would want it to be, and even better, because there are no pesticides. So how can you, why do we have to use pesticides if you can actually do it even without soil, only with water. Why are we doing that?
I think that a lot of vertical farms, you know, have been established. How can I say? There's one small drawback we have to figure out. That's because we need a lot of. We're using artificial light to really be very efficient in the production. Because in the Eden Ice greenhouse, we had 10 square meters, and each week 5 kilos of, you know, tomatoes, cucumbers, lettuce,
Wow.
basil, so a lot of yield and a lot of produce. And to achieve this, it's really about the specific lights, the how can I say, the tuning of the light spectrum in the blue, in the red, and in the white, and that is energy. And we need to also look for, you know, not only look at greenhouses or these vertical farms themselves, but also at a whole system, how we can produce the energy and kind of bring it into a circular system. And that is interesting, and that is necessary for space, but it's also very interesting for these larger, you know, urban areas, or, you know, mega cities and so on.
Absolutely. I mean, it sounds like actually if it kind of arrives in the urban life, then people could use, you know, their space if they want to grow their own crop, because 5 kilograms of cucumbers and potatoes and tomatoes and salad is like really a lot. unless you have huge families, but it's not too bad actually. I don't know. I don't think
the greenhouse, the Eden ISS greenhouse, is located at the Neumeier 3 station, the German Antarctic research station. And I think at one point they had so much salad and basil and I don't know, they were already fed up with, you know, fresh vegetables, because it just, you know, there are 10 people overwintering. And they had a lot of fresh food, but it was so successful, and the crew, the overwintering crew, was so also charmed by the opportunity to go somewhere in a very isolated and you know, confined area, and to have a place where they see something grow. And for example, these cucumbers, I mean, we never see that, but they have these really nice flowers, you know, these white flowers blossoming. And so it's a really nice change in the environment. And so that is also something which is good for the psychological well-being, especially in isolated places in space. And also just to see some things growing from a small seedling into, you know, a larger plant, and then into something we can eat and enjoy.
Yeah, absolutely. Yeah, that's really, that's fascinating, and that's beautiful at the same time, and meditative. You know, coming back to Earth, very much worldly. I have all the things that you're not interested in growing in a space station. I have sugar. I have eggs. No chickens in space yet. And I have hazelnuts. So I'm going to be doing a you know, small hazelnut how do you say, cake. I'm going to bake tonight. So, you know, as we talk, I might sometimes go on mute, so don't worry about it. It's because then I'm mixing and I don't want to bother you.
All right.
Yeah, so that is really, really amazing. Let's go back a little bit and talk about, I mean, does that ever happen to you, that someone comes to you and says, why on earth would you go and become a space architect? Or, you know.
I think that, I mean, yes, that I think amongst the architects, they all get inspired and they know a little bit. I think space has become more, you know, more prominent in the heads of the architects or artists. But but normally people really, you know, ask, you know, how did you get into that, and why? You know, it's so far away, it's in the future, and it's you know, when will you ever be able to build something? Will you ever be able to build something? Which are all good questions. And I think it's, for me, it started with being interested in the future. You know, how will we live in the future, and where will we live? you know, what kind of societies and what kind of environment and architecture we will live in. And I think this is what made me, you know, do some research and go a little bit further and go into do a Master of Space Studies at the International Space University. So I come from an art school. That's funny enough, because you would always think, you know, it's you need to you know, do all the maths and so on, which I did. But I also have a very strong artistic background, and I studied in Vienna at the University of Applied Arts with one of the enfants terribles of architecture, the Wolf Brix, Coop Himmelblau. And so I think that was very inspiring, and always, it was always about the future. And yeah, and after my Master of Space Studies, I had the opportunity to work at NASA. And I think it was just step by step. I just was kind of, you know, taking that path. And I think at the end of the 1990s, we were maybe 5 or 6 architects working in that field. So yeah, but at NASA, I have to say, and I have to show you, I worked on a Mars mission. So my job as an architect was to design, or to co-design, not on my own, of course, a test bed for a Mars mission. So it's basically a structure of different habitats where people could live, and where they could mimic, simulate a Mars mission. So there was a habitation module, which I was, you know, doing some design for. There were 2 modules for a greenhouse. There was one just for all these recycling systems, you know, recycling air, recycling water, life support systems, we call that. And then there was, of course, a big science workshop, a laboratory. And so people were, you know, there was nutrition specialists, and they were thinking about, you know, what would be good to eat on Mars? You know, what is like the, you know, it has to be something which is, what should we grow, you know, in our greenhouses? And that was, you know, that was before Eden ISS, and, you know, many years back. And so they came up with the sweet potato. I'm not sure if you can see that well, but so the sweet potato has everything. And they started creating recipes for sweet potato pies, for cakes, for bread, for, you know, anything you can imagine. And so this is, you know, the sweet potato has everything, because it has carbs, it has fibers, it has vitamins, it has sugar, there's everything in there. And so they tested this, and that's why I also prepared a little, you know, recipe with sweet potato. That's the space, you know, very simple one, just sweet potatoes and some dried apricots and some grinded orange peel with some orange juice, and then bake it in the oven. So that, you know, it could have been possible on Mars, let's say, right after some you know, additional cargo coming from Earth as a surprise, let's say, because the oranges are a little bit difficult, you know, fresh oranges. And the oranges, the interesting thing about the oranges is, I have one here, that so they also get that, the astronauts get these on space station. And when you start, you know, grinding the peel a little bit, and then it starts smelling really nicely. So actually the astronauts love these oranges for their fruits, but also they keep the peel because it is a nice smell. And, you know, and a space station, just imagine, you know, a room you never vent, you know, it's always the same air, you know, somehow recycled air. So you're really happy for some good smell and odor.
Yeah.
So this is
really
the optimum space meal here for Mars.
That's amazing. So it's like So, I mean, how does that work when you imagine a future or imagine a habitat, especially for as I've heard you say, extremely hostile environments, right? So where actually nothing grows, nothing can live without life support. Um, how do you go about that as an architect when you know that that you're thinking about extreme environments? And I also know that some of your projects, although they are not being put into life in space yet, because the technology is not that far, but you're using some of those, like the Eden ISS on Earth, on extreme habitats on Earth.
So how we go about designing these? I think it's a collaborative. It's a very much collaborative process. In our company, we have space engineers and scientists and architects, designers. That is very helpful because everybody has a very different mindset and starts from somewhere different. So I think coming together and also because space systems are very complex, it's good to have every angle from the start, because you don't want to leave out something because you can't afford it. You have to think it from the system's perspective, and then maybe a good example is the next space station and the interior configuration for the habitation module. The next space station is called Gateway, and it's circling around the moon, and it should be the gateway to the lunar surface, but also further to Mars. So so here, I think there are a couple of requirements. And most times it starts with a scenario. Mm-hmm. So if we don't create the scenario ourselves, then it's sort of given by, let's say, the space agencies, and then they would mm-hmm. say, okay, you have a rocket. The rocket is capable of carrying 8 tons and mm-hmm. let's say a diameter of 3.5 meters and length of 5 meters, let's say a very simple module. Mm-hmm. And, we want you to design a habitable space where 4 astronauts can live for a month mm-hmm. in a lunar orbit. They have to they have to work, they have to have their own individual crew cabin, they have to have a kitchen, mm-hmm. because this is where people come together. And this is, we can see that. We are demonstrating this. And yes, and so I think this is the brief. We start from a brief. Mm-hmm. We might always, rethink the brief, or we will always rethink the brief and think, okay, is there everything there? Or can we, because some people might think, okay, privacy is, let's say, is not that important, but we think privacy is very important. So we try to really to extend the brief and say, okay, every person really needs a private cabin. So maybe we have to make it deployable. And so it's a lot of being creative, being pragmatic, looking for workaround solutions or for more radical solutions. I think this is, and also designing to the engineering requirements, which will always be very prevailing in the end.
Yeah, well, you already have a question actually. How big is the market for space architecture? I assume there are only a few customers.
Yeah, well, I think it can't be measured like this because, let's look at the Eden ISS project. They're a research and development project. So it's not a business as such. One could derive products maybe from that area, from the business. And let's say if I create a good idea of a deployable private space, I could transfer it into a terrestrial application and then make that make it a product and bring it to market and create a business like that.
Yeah, and you already spoke about circular economy. You can hear me, right? Okay. You already spoke about circular economy and, you know, also creating circular systems. And does it happen to you that you sometimes walk through life on Earth and you actually are someone who knows what is possible already? And you go about life and you're like, and if yes, what are some of those things?
Well, personally, currently, I'm really concerned with trash.
Mm-hmm.
And interestingly enough, that a lot of our studies for the European Space Agency, for example, they are concerned with using the local resources, and if you consider and reusing things. So we had this very interesting project where we actually looked at, okay, what's needed on a lunar base, really, what kind of laboratory equipment, what kind of, some, bowls for eating, some cutlery, some, anything, basically. And how can you 3D print it, or, take the material you have, reuse it, put it into a 3D printer, and make something new out of it. So it's really
why would you want to 3D print in the first place? Is it because it's like too heavy to take with you, or?
Exactly. So you could,
okay.
You can use the sand, the lunar sand, for example, to 3D print a habitat.
Wow.
And so you start off, this is the moon, you have the sun, you have the sand, because the moon has no atmosphere. You have an abundance of sunlight there. It comes straight down to the surface. You have a lot of lunar dust there, and you can use a 3D printing additive layer manufacturing technology of solar sintering in the way that you lay a sand layer upon sand layer, and then with a concentrated solar beam, you glue these sand layers together into bricks. And this way you could create this protective space for a habitation area, for a habitat.
That's amazing.
And so in that way,
sorry.
the how can I say, trash is not even, everything you have is a valuable resource. Even if you bring something, you'll never, because everything's so scarce in space that trash is no option.
And when you think about our Earth and our life on Earth, so you said that trash is something that makes you really think twice. And I mean, if we were to redesign the systems we already have on Earth, where would you start redesigning?
I think we have to give a little bit, as architects, we think we're only concerned with the building envelope and the interior, and the design, of course, of the context, maybe, the outdoors or this urban context. But I think we have to give a little bit more, you have to think more about the, all the systems, the heating, the climate control, and so on. We have specialists, but I'm not sure if we're, really working very closely together with them to find a really good and more circular solutions.
Yeah, I also think that it's going to be, I mean, it is already extremely important, but unfortunately not really being valued as it should be. Sometimes you think like future is already there. We just need to stop living in the past, right?
Yeah, I mean, the other thing is that regarding material, everything needs to be certified. It's the same with space. So here on, on Earth, on terrestrial grounds, we have, of course, a more possibilities to choose materials, but in the end, they all have to be, certified. And I think that sometimes, you know, that also hinders the development of new materials and other materials, or it becomes quite, cumbersome, for ingenuity in that respect. So, there are adaptations to materials or kind of further developments, but to introduce something completely new is quite difficult. And that is also true, for standards regarding, plumbing and heating and so on.
Very interesting. And so there are more questions here. One of them is really cool. It says, do you personally optimize also your personal space as if you would live in a spacecraft in real life?
That's a good question. I think in many ways I have to, because the flat I'm living in is not that big. And through time, everybody knows that one acquires quite a lot of stuff. And
absolutely.
And yes, I think it's. But of course, I mean, as everybody else, I'm just a human being. So I'm sure there's corners where people, would look into or look at and think, oh my God, that's completely,
that's
not rationalized. That could, get a little bit more organized or something.
That's hilarious. So when do you think is the first IKEA, shop will open up in space? Design your home. So another question is, do you have a personal fascination with space travel? Are you a Trekkie?
Well, yes, I think so. I think I grew into it. I wasn't, some people, they always wanted to be astronauts, when they were little or so. But I never wanted to be that. I was more concerned with the environment and sustainability as a teenager. So for me then, years ago, it was a kind of how can I say, aha event or so, when I realized that that my original interest in the protection of the environment and so on, that somehow was also one of the aspects when you had to consider when you go to space. But then, of course, being, so that was the question, was more regarding space travel. I mean, I would, if you give me a ticket to the ISS, I would go. I mean, just imagine being in zero gravity, having this fantastic view, best view ever, onto that, blue planet. Fantastic. To the moon? Yes, I would also go to the moon. To Mars?
To Mars?
Not sure. That's really far away. And maybe I know too much about, what it would take, that, a little bit cautious.
Yeah, so you're not in the first flight to Mars. Is there a material that is used in space already that would be really cool to use more on Earth?
Oh, there's, many people say Velcro. We're using it, everywhere, and that's a kind of, was actually developed for space. And when you look at all these pictures in the space station, then you also realize that actually there's Velcro everywhere on the walls, because it's all floating, and you just stick something to the wall so that it stays in position. So well, there's many there, but some things, they were developed, and I think they were then appropriated for space, but they weren't, they came out of some needs. Let's say for spacesuits, for example, it's the outer layer of spacesuits is Kevlar. That's an aramid fiber, and it's very, it's woven in a specific technique. And it's like a bulletproof vest. So it's also used for bulletproof vests, because, in space, you have these micrometeoroids flying around, which would, burn up in the atmosphere, but you're beyond the atmosphere. So you have to have some protection.
That's very interesting. And I mean, when you think about the space, some of the space startups, let's say not necessarily in the research and development realm, but especially in raw materials realm, it looks like humans are interested in going into space, not because of a romantic notion, but to exploit it. What do you think about that?
Well, I like the Outer Space Treaty from the early 1960s, which actually says that space belongs to all of us, because I like the vision behind it.
Why us, actually?
To all of us, you know, everybody on the globe.
Yeah, what I mean is like Earth is not the only.
Well, Earth is, you know, you can buy land on Earth, and it's quite, you know, how can I say, it's quite sold out, you know, it seems. Yeah.
No, what I mean with when one says space belongs to all of Earthlings, then it sounds already weird.
Okay, it sounds quite imperialistic, you mean? Yeah, that's an interesting aspect. Never thought about it. Yeah.
Why? Yeah, I mean, yeah, we are already having lots of trash over there, and people are thinking about how to clean it up. And yeah, so let's go back to the question. Sorry, I didn't want to take a detour, but
remind me of the question again.
The exploitation of the raw materials.
The exploitation of the raw material. Yeah, so I'm not sure, you know, will it then be, you know, the Amazons of the world who'll exploit it, and you know, where will it go? And you know, while I think it's interesting to look at resources, I'd rather would see how can I say, a more Antarctic model, where we still, you know, where we let's say have our research bases on the moon, but you cannot claim land on the moon. And then, you know, one has to sort of maybe trade or think about, you know, touristic adventures or some more commercial adventures. I don't know. I don't have you know, a final opinion about it. I'm interested looking at it, seeing what's happening. I think they're very cool developments, but I also remain skeptical. It's I think it's being discussed, so I think we'll see what comes out of it.
Absolutely. And I mean, when you think about some of the famous science fiction literature, it looks like, you know, humans enslave space, humans enslave robots, everything is kind of in this imperialistic notion. And then, you know, I don't know, we still have fights, we still have wars in this, but just in a different space. So when you envision a future, what kind of future do you think about? How are we going to live together?
In space?
Well, including space.
Including space.
and especially nowadays, you know, with the social distancing, we might expand.
Yeah, it's pretty much like in space, you know, you're mission control and I'm on this spaceship here.
Exactly. Yeah.
We're having a conversation. How do I imagine it? Well, I think all the inclusive, I mean, there are many emerging spacefaring countries, and it would be nice to also include them. Today, for example, the International Space Station partners who work together on the International Space Station, NASA, so the Americans, the Russians, Roscosmos, the Japanese, JAXA, and the European Space Agency and the Canadian Space Agency. I think, you know, if you know, I would wish that, you know, the future project would also incorporate the Chinese Space Agency and maybe the Brazilian ones or the Indian Space Agency, so that it'll become more difficult, more challenging as a project. But I think, you know, a sort of space station which is global or which can be accessed by any country, I think that would be a nice vision, because this is, I think, from for the International Space Station's perspective, that's already, I think, one of the best, the greatest achievements is that,
Mm.
whatever is going on Earth, between America and Russia in space, they're still there, they still collaborate, and they work together and live together.
Mm-hmm. And why is it so? Actually, that's the next question I wanted to ask. Why do we seem to be able to collaborate outside of the terrestrial grounds in a more or less harmonious way? And then, so what is the common goal there?
Well, I think first of all, there is a common goal.
Mm-hmm. Yeah.
Which is important, and
Okay.
everybody signed up for that. And I think, and then there is a sort of economic necessity. None of these nations could afford a station of that size on their own, so they had to partner. And I think that is, so. And the goal is to run this station and to do experiments, and they have been extending the lifetime of the International Space Station over and over again. So I think now it's going to be there until 2028 or so. Okay. But it was originally only conceived for 20 years, which should have actually should have been terminated, the use of the International Space Station this year or so.
Okay.
It's a very unique and delicate project.
That's really, I mean, it is actually a great project that shows that we're able to collaborate when we are able to find a common goal. And, so I'm hoping that the common goal is not necessarily going to be a pandemic, to have something that, about, because obviously we're able to collaborate in space even without a direct threat to humanity. So we don't have to have wars to be able to collaborate. So another question, and that's going to be the last one: do Earth deserts provide any good possibility?
Uh-oh.